First, let's see the circuit of half-wave rectifier. The transformer primary is connected with the 230 volt AC supply. The transformer secondary is connected with the half-wave rectifier circuit. This is actually a 230 bar 606 volt transformer. The half-wave rectifier circuit arrangement is shown here. It simply consists of a diode and a resistive load. The secondary terminals of the transformer is connected with the diode rectifier circuit as shown in the circuit diagram. This is how we have done the connection using the breadboard, diode and the resistive load. Both the input waveforms and the waveform across the load is observed using the CRO. We are using a 2-channel oscilloscope to view both the input waveform and output waveform simultaneously. Now what you are seeing is actually the input waveform. You have to plot this waveform in your record. Now let's see the output waveform in channel 2. Switching into channel 2. This is how the output waveform of single phase half wave rectifier looks like. This is how you will be able to see the waveform of single phase half wave rectifier. So far we have seen the output of half wave rectifier circuit without filter. Now we are going to see the effect of capacitive filter on the circuit. See, while adding the capacitive filter, you will be able to see the change in the output waveform. See, the ripples has been tremendously reduced and the output seems to be more DC in nature. This is how we have added the capacitor to the circuit. The capacitor has been connected in parallel with the resistive load. The capacitor used here is 100 microfarad one. You have to plot this waveform also in your record. First we will see the arrangement of full wave center tap rectifier without filter. Just like in the case of a half wave rectifier, the secondary of the transformer is connected as input to the center tap rectifier circuit. The center tap rectifier arrangement is done by using two diodes and a resistive load. The connection is made in accordance with the circuit diagram which I have shared with you. First we will analyze the output waveform without the filter and then we will analyze the output waveform with filter. The input waveform remains the same as that of the case of a half wave rectifier. This is how the output waveform seems to be in the case of a single phase full wave center tap rectifier. Comparing with the waveform of single phase half wave rectifier, here we will be getting the output waveform for both positive half cycle as well as for negative half cycle. Now let's see the change in waveform while connecting the filter in the circuit. We will be connecting the filter across the resistive load. The filter which is connected here is actually a capacitor of 100 microfarad which is connected across the resistive load. That is the effect of filter when it is added to the rectifier circuit. The output becomes more DC in nature. That is, the pulsations are very much reduced. In order to obtain DC voltage from AC input voltage, the next circuit we are going to see is actually full wave bridge rectifier circuit. This consists of 4 diodes connected in the form of a bridge, and the load which we have used here is resistive load. That is, we are actually using a resistor here as the load. As seen in the connection diagram, the secondary of the transformer is connected to the input of the bridge rectifier circuit. The circuit arrangement can be seen here very clearly. First we will analyze the circuit without the filter and then we will connect the capacitive filter and then we will observe its waveform. Without filter, The output of single phase bridge rectifier using diode seems to be like this. We will be able to get the output for both positive half as well as negative half of the input AC voltage. Now let's connect the capacitive filter and let's see the change in output waveform. After connecting the filter, the output waveform seems to be more DC in nature, that is less pulsating one. This is how the output waveform seems to be under the influence of capacitive filter which is added in parallel with the resistive load.